can control the pressure of the vacuum from here, as you can see. Once the vacuum is on, the photo mask get fixed with the plate, so it cannot, it will be fixed, so it will not move here and there. Once this, it will get vacuuminated. After that we will place it carefully at this. Now we will adjust the alignment of this photo mask by viewing on this machine. We can use this pen to scroll up and down using this. Another thing is that this is a substrate holder. This circular plate is used to hold the substrate, which is kept on the circular disc called wafer. On that wafer substrate, usually a glass substrate, quartz substrate is kept. After that, it is slide inside like this. Once the alignment is fixed, we can tune the alignment or can adjust the alignment by using these controls. Can be used to move the wafer left to right, and these can be used to move the
left to right. This one.
Illumination left to right, and this can be used to make it forward and backward. Once we
all
are
6 sides we can control.
Yes, sir.
We have 6 kind of screw gauge. We can control micro screw gauge. We can control the height, tilting. We can control the width, length. 6 sides we can control.
The height can be controlled from here. This is used to adjust the height. Once we are done with the alignment, the mask is fixed at the optimized place by tightening the screw.
It's lithography.
And once this is done, the light illumination process can be started by switching on the switch over here, illumination switch. The illumination of the light will take place from this, and
there is a shutter. There is a shutter inside. The shutter will come out. Right? This is take it upsides. The shutter will come out, the UV light, and light is illuminated on the mask. There is 2 types of mask. Mask means the where the surface is coated, that light will not penetrate, will not illuminate it on the substrate. There is 2 parts. Where the light is illuminated on the substrate, that means then we have to develop. Where the light is illuminated, that is fixed. Not illuminated, that is we can remove with the help of acetone, methanol, means kind of solvent. And we can take out the mask, and we can fabricate with etching. The etching is 2 types, mist etching or dry etching. So mist etching होती है 2 types है, wet chemical etching or dry etching. Dry etching we can do in the sputtering, or wet chemical etching we do in the by particular solvent. After etching, then we have to clean, we have to check the depth, how much depth we have fabricated, and we have to check again and align the mask. If the mask is fixed, then we have to make some bridge. For bridge making, means we have to coat the negative photoresist, means we have etching the grooves. The negative photoresist will be fill up and will be smooth, and then again match the mask, and the illuminated again, the UV light illumination. And that is fixed, then we have to coat the metal coating. So metal coating, there is a bridge is completed. You can see that fat, there is a kind of bridges. I explained the class, right?
Yes, sir.
There is bridges. So bridge means we have to coat the negative photoresist, and after making the bridge, then negative photoresist we can remove it with the help of chemical etching. And the completely our design is completely fabricated. Then we have to go for a contact, we have to go for the IV measurement to test the device is live or device is dead. So if we are making 1000 devices one time, maybe 50% died, 50% just active. So this is the process of mask calendar system. So this is the role of microscope.
मतलब died more live में मतलब कि
that means 1 inch area we have almost 1000 device or 2000 device. So maybe some device is not working, maybe not proper aligned.
Yes.
Means that means not working. That means that device. We call it that device. So live device, I have shown some of the devices. We fabricated 1500 devices. We got in first round, I got 40 devices only. The rest of the devices were dead because that was my first experiment. So this is the process. So we have to protect. So the compact device is more expensive. Why is it expensive? Because of many devices are dead, and we cannot recover the material. Or bridge we are making the metallization by the gold, 100% pure gold. This is very expensive. The yellow, you can see the device, that is a pure gold. But we cannot recover easily. So some scientists in NPL, they are trying to recover the gold, they are trying to recover the silicon, they are trying to recover the indium tin oxides. So they are in that process. Okay, this is the complete explanations. Thereafter, we have to do fabric development lab, the another room. Okay, thank you.